Databases are the backbone that turns isolated AI agents into powerful data-driven systems that allow agents to efficiently store, retrieve, and analyze structured information, enabling smarter decisions, better automation, and seamless scalability. Today, we'll explore how to integrate Supabase, a PostgreSQL type database, with AI agents using PydanticAI. We'll look at how to structure our tool interactions, explore best practices for performance, and walk through a hands-on example that brings it all together. All right, let's dive in and make your agents truly connected. This video is part of the Full Stack Agentic AI with PydanticAI Masterclass, your roadmap to building powerful, production-ready AI agents. In this series, we cover everything you need to know, from choosing the right framework to fine-tuning agent workflows, integrating APIs, optimizing prompts, and even deploying your AI-powered agents to scalable cloud infrastructure. In today's session, we're diving into building database-capable agents that can connect to and perform all basic CRUD operations on a database. We'll use Supabase, a popular PostgreSQL-based relational database, and PydanticAI with context-aware tools. You'll learn how to create database tools, perform retrieval and creation queries, handle exceptions, and create powerful database agents for your next agentic flow. But before we dive into the technical details, let's talk about why database access is so crucial for AI agents. First, let's take a look at database agents from a business perspective. Why is database access so important? The first factor is data consistency and reliability. Storing structured data in a database ensures that the AI agents have a single source of truth. When you get to more complex systems with multiple agents spanning across enterprise systems, having a master data source, single source of truth, is so important. Next is scalability. Databases allow AI agents to handle increasing volumes of structured data efficiently, supporting business growth. And finally, compliance and security. Many industries require data traceability for security and governance perspectives. So that's where the database plays a critical role. But what about the technical reasons? Let's take a look from a technical standpoint. And here are some tangible benefits. First, efficient querying and retrieval. Databases are probably the fastest way to get to the source of data. Secondly, integration with external systems. AI agents often need to interact with CRM, ERP, analytics, you name it, many downstream enterprise tools. And the best way to do it is through database-enabled tools and agents. And finally, long-term storage and analysis. AI agents improve when they have access to historical data for trend analysis, training, and fine-tuning. Whether you're scaling microservices, integrating AI agents, or automating workflows, adding database access to your agents is essential for creating truly useful agentic systems. Okay, what we're building today is a CRUD-enabled agent with PydanticAI that will have the 4 critical operations. Create a record. We're going to use a tool to create a record in Supabase, retrieve a record, update a record, and delete a record. So those are the 4 CRUD operations typically found in a database system. Before we continue though, let's take a look at a couple of diagrams that are going to explain these CRUD operations. Let's start with our creation. In the creation workflow, we have the user issuing a command to the LLM. And the command will be something like create a new customer with the email brown@al.com, name of Jim Brown, and bio adventure extraordinaire. One thing you'll notice is that is all human language that will be passed to the LLM in step number 1. In step number 2, the LLM will parse this human sentence and extract key details with the help of the tool. The key details will be passed to the tool as a JSON format. So the LLM will extract the email, the full name, and the bio. Then the tool will make a SQL query to the Supabase database. That will happen in step 3. And the SQL query will be something like insert into customers, email, full name, bio values, and then the extracted values from our human sentence. Once that operation is done, the tool will then return to the LLM, and the LLM will provide the answer to the user in step 6. And the answer will look something like new customer was created with the email brown@al.com with the name Jim Brown and bio. If there's an error, the error then will return to the LLM and nothing will be processed. But this is a basic create interaction diagram. I put this together because these steps are important to understand. This is so critical to understand where the interactions with the database happen. And the only interaction with the database here is from the tool. We'll use this similar pattern in the retrieve, update, and delete diagrams, which are coming up next. Now, retrieve is very similar, but the language and the query will be different. So that's why I put together a separate diagram for this. The language will be retrieve customer details for customer with the email brown@al.com. Now, this is important because our tool, the way it was coded was to query customers by email address. You can change this query any way you like. You can query by email, by social security number, by multiple values. You could say, give me customers that have placed an order in the last week for total order amount over $500. So that would be a little more complex query, but I wanted to keep it simple. So we're only looking for customers with a particular email. Now the LLM will extract that email from our question or prompt and pass it to the tool. The tool then will use the SQL query select star from customers where email is equal to brown@al.com because that was the value that the LLM parsed. And everything will repeat. The tool will retrieve the record from the database and pass it back to the LLM. The LLM will put it in a structured output and give it back to us or just provide a sentence with the text. So this all looks quite straightforward, very similar to the create pattern. Now, let's take a look at the update interaction. In the update flow, we have something similar. Let's go with the language first. Update customer with email brown@al.com to the name of James Brown and bio godfather of soul. So now we're changing two fields. We're changing name and the bio, and we're searching for the record by its email address. Again, update queries can get complicated and feel free to experiment with this, but our SQL query in step 3 will be as simple as update customers, full name, email, and the values passed where email is equal to the provided email. This information will be passed to our tool by the LLM, which will parse it from our prompt, and it will return the record. So that's a simple update interaction diagram. Now let's look at our last one, which is the delete sequence. In the delete sequence, we have something similar to the retrieve. Our prompt is quite simple. Delete customer with email brown@al.com. So parse the email address, pass it to the tool, and the tool itself will make the query to the database, and the query SQL is delete from customers where email is equal to the past email. And the returned value will be the record, the deleted record. Quite simple, but these diagrams, hopefully all interactions, the create, the retrieve, delete, and update will give you an idea how to structure your agent with database access. With that, let's move on. But before we go into the coding examples, let me tell you about the new school that I've started. It's an exclusive community of learners unified with the mission to learn about AI in software development. We meet weekly. We discuss topics in tech, YouTube resources. There's an exclusive library in the classroom with classes only available for the school students. So you get access to all the exclusive examples, long versions of the videos, and the source code. So it's a really, really good opportunity to get motivated, to work on your projects, to learn a lot and improve your AI skills. I sincerely hope that you'll check it out, and I'll see you there. Okay, so let's start the coding tutorial. The plan is first to download and install Docker Desktop. We need Docker to run Supabase. If you'd like to use a different database, feel free to skip steps 1 and 2. It will likely be very similar in steps. You just need to change the connection information. In a previous masterclass for PydanticAI, I presented an example with SQLite. It's a local database. It's a very simple database. So if you'd like to just follow along the SQLite route, feel free to skip steps 1 and 2. I purposely added them here because Supabase, based on PostgreSQL, is a very capable enterprise-grade database that if you choose to use, here's one way for you to learn how to do that. And the easiest way to install and run Supabase on a local machine is through Docker Desktop. You can run it without Docker, but just takes a little longer. So feel free to download and install Docker Desktop. I'm not going to cover Docker installation and configuration here. I'll just assume that you have Docker running on your machine. Docker Desktop is available for Windows, Linux, as well as Mac OS. I'm on a Mac OS MacBook Pro M3. So it runs with no problems. We're going to start the tutorial with steps how to install Supabase, and then we're going to create and configure a single table in our database called customers. In that table, we'll create our columns, and we'll create a unique column index for the email, and we will disable row-based security just because it's going to make our operations easier. Next, we're going to create our basic agent, no tools whatsoever, just a seeding function. We're going to do a quick test drive. If everything works, then we'll start adding our tools one by one. We're going to create our CRUD tools in 4 short steps. Then we're going to test our agent, and then we're going to call it a wrap. All right, so that's the plan for today. Let's move on. Now let's start with our Supabase setup. The first thing we want to do is to go to the supabase.com website and look at the guides/local development. If you land on this page, you will see that there are multiple ways to install Supabase locally. You can do it through npm, yarn, and brew. So whichever works for you, choose that method. For me, the easiest was to use the npm way because I already have Node installed. So it's easy to just copy and paste this. So what we're going to end up doing is it's only 3 steps. Copy this first command if you have Node.js working. So I will go and navigate and now open my iTerm. Once in iTerm, I'll just paste this, ensure that I will have Supabase installed. Now, I've already installed this. So when you go through this for the first time, it's going to take a while. So it's going to download a number of packages as well as Docker images. So be prepared to wait, depending on your connection, anywhere from 5 to 15 minutes. So now let's go and copy the second command, which will be npx supabase init. And because I already have it initialized, what I'm going to do is I'm going to use the flag --force to reinitialize it. Let's go ahead and do that. I use Supabase init --force, and it will reinitialize it for my system. All looks good so far. Next, we're going to grab the third command. It's the npx supabase start, and this will launch our containers inside our Docker environment. Let's paste this, run this, and as soon as you do this, take a look at all these values that are being displayed, copy and store them in a secure location because you will need these into the environment variables later on once we start building our agents, especially the API URL and the DB URL are 2 values that we're going to use, as well as the anonymous key. My environment is working, Supabase is working. Let's go ahead and confirm that. What I'm going to do is launch my Docker Desktop. Once inside Docker Desktop, I can already verify that all of the images are working and life is good. Now what I can do is launch my browser and hit the Supabase Studio page from this URL. So I will just copy the Studio URL, open a web browser, paste it there, and voila, I have my introduction page in the Supabase. If you get to this page at URL 127.0.0.1 and port number 54,323, that means your Supabase installation was successful and your server is running. This is the welcome page, and on the left, you can explore different options. So the first link is the table editor, where you can manage your tables, create, delete tables, and do operations on the tables. The next one is the SQL editor, where you can run SQL queries, and so on and so forth. So the purpose of this tutorial is not to go in depth into Supabase interface, but what we're going to do now is we're going to create our customers table. So click that table editor, the first link, and you have 2 buttons here. On the left column there, right above my cursor, you see the plus new table button. as well as in the middle of the screen, because I have no tables created, you have the green button that says create a new table. So you can click either one of them and it will open the new table editor. So on the right hand side, this column is the new table editor. What we're going to do is name our table customers and put a simple description, store customers table. And right there in this interface, what we're going to do is disable the row level security. This is not recommended for production systems, but it makes life easier when we're doing development. So we don't need row level security. We're just going to disable it. Okay, so it's just warning us that do you understand the risks? We understand the risks. We're in local development. No worries. Next is our column definitions. This is important. There are two columns that come kind of standard with the table. The first one is the ID, which is a auto-generated integer. And the second one is a created at, which is a timestamp. I will just keep them because it's good to have a primary key of ID auto-generated, and the created at is another good column. So I have no problem. But what we're going to do is add 3 new columns. So go ahead and add that add column button and name the first column email and put the type as text. So what we're going to use it is just a standard text. Add one more, call it full_name, also of type text. So populate that. And the third one will be a simple bio. Just name it bio and put it as text as well. At this point, you can just go ahead and hit the save button. It will save the table. But there's one more small thing that we'd like to do before we close the table editor, and that is make the email column unique so that when we run our seeding script, it does not repopulate the table with duplicate rows. So if it finds a row with the duplicate email address, it will just basically skip it. We're going to try catch that exception, so nothing will happen. We only want to seed our database once. So it's also a good idea to make the email fields unique anyway. So what we're going to do here is you see the table, find the email column, click the drop down menu and click the edit column. In the edit column, scroll down, you will see a toggle is unique. Let's enable that toggle and make the email column unique. And now our table is saved and our setup is ready for our agents. It's 3 terminal commands to install Supabase. It takes about 10 to 15 minutes. If you already have Docker Desktop installed, creating a new table manually, it's also quite easy with the Supabase web interface. You can also do this through a script, through a DDL script, create table and column definitions. That would be a way to automate this later. But for this tutorial, creating it manually makes more sense. All right, now let's move on. Now that we have Supabase set up, our table created and ready, let's go ahead and create our basic agent. In this first example, we're not going to add any tools. We're just going to add a plain agent, and we're going to finish by testing a simple seed function just to ensure that we're able to access the database and add some data. But before we start, let's ensure that our Supabase table is empty. We can just go ahead and open our Supabase Studio page and ensure that customer table is empty. Now let's go back to Visual Studio Code and start coding. Import os import.env. For today, we're going to use from PydanticAI agent and run context. We're also going to use from Supabase create client and client libraries. These are all going to be included in the Poetry file, so you don't have to do anything but just install the Poetry dependencies. We're also going to need our Grok API key, so make sure to get your free Grok API key, as well as copy paste those values from your terminal and add them as environment variables into your .env for Supabase_URL and the Supabase_key. Okay, client is created with the function create_client. That's line 16. We're going to use the Supabase variable of type client. And to the client, we're going to pass the URL and the key. Let's go ahead and create our customer Pydantic class. It will have an ID, email, full name, and bio. That's the customer class that we're going to use throughout the agent calls and the tool calls. In line 27, we're just going to make sure that we have the Grok API key set, and if not, we're going to throw a value error just to warn the user. On line 31, we're going to use a simple method called getModel. We can just pass any model name and get it from the Grok library. For this, we're going to use the Llama 70 billion parameter model for today. Our system prompt is: you are a customer service representative for a tech company. Use the tools provided and assist the customer with their queries. Agent definition is: we're passing the model with get model Llama 3.3 70 billion parameter, and the result type will be of customer. So we want our agent to always return a structured customer type, and the system prompt will be the system prompt. Here's our seed database method, and inside this method we're just going to use the Supabase client.table. We're going to specify the table name as customers, and then create 3 rows for John Doe, Jane Doe, and Jim Doe with a simple email and bio for each of these rows. Okay, so that's our method, and we're going to call our method inside our main loop. Here on line 64, we're calling the CDB method, and then we're going to create a simple loop where the prompt will be to ask the user for their question, and then the assistant will answer with something that is appropriate. We're going to run at the try catch block on line 72. Result is equal to agent run sync, user input, and as dependencies, we're going to pass the Supabase client class. So this is really important because we're going to use these dependencies in our tools later on. Make sure to not forget to pass this dependency. This is using PydanticAI's unique dependency injection mechanism. We have videos on the PydanticAI masterclass about that. If you need help, just go ahead and watch those dependency injection videos. In the except blocks, we're going to watch for value errors and exceptions, and if any of those are thrown, we're just going to print an error message in the terminal and move on. Our basic agent is ready. Let's go ahead and open the integrated terminal in Visual Studio Code, and the way to run this will be through Poetry. So we're going to run Poetry space run space Python space agent.py, and that should execute our script. So let's go ahead and do that. And as soon as we run our script, we don't need to type anything other than hello, and this will kick our seed function. And as we can already see, there's a return type here. This is irrelevant, but what we need to do now is go to our Supabase table, refresh our table, and see that the 3 rows have been populated successfully. That means that our script is working, our connection to Supabase is working. So we can just go ahead and do one more test. We can quit this execution and start it one more time and run the agent, and again type a simple hello and execute our seeding method. Now if we go back and refresh, we will see that we still only have 3 rows, and the reason for that is because we made the email column unique. So we're not going to insert unlimited number of rows. It will just end with 3 mock data rows, and this is super important. If you try to install duplicate data, that's not going to work because of the constraint we put on the email column. Now let's go ahead and clean our table, select our rows and delete them. So now the table is empty. Let's go back to Visual Studio and quit this execution. Start our script one more time just to ensure that it's working. Type hello, wait for the execution. Now go back to Supabase and ensure that our rows are there. First, they're not, and now if you hit the refresh button, they're already there. So that means our agent is working. We have a basic agent, no tools just yet, but we're able to insert mock data into our Supabase database table. Okay, now let's move on to our first tool. Now that we have our basic agent up and working, let's go ahead and create our first tool, and our first tool will be the create tool. Inside our script, agent.py, let's add our tool with the decorator at agent.tool, and we're going to use the retry with 3, and we're going to name our tool create_customer. It will take the run context as a client, and we're going to pass the Supabase client. It will take an email, full name, and bio. Now remember that these values will be parsed by the LLM and will be passed to the tool during runtime. So it's really important that we have the right parameters passed to our tool. So our tool is a context-aware PydanticAI tool. It will take the context, and we're going to pass the Supabase connection as part of our dependencies inside the agent, as we saw in the previous agent definition. And now all we're doing is passing the email, the full name, and the bio. What we're doing next in the try block is the context.depths.table, which is supabase.table, and we're picking our table as customers, and then we're running the command .insert with the email, full name, and bio passed as parameters. It's a very simple way how to insert records into Supabase. And then we're catching the exception, and let's run our query. Before we enter the query, let's go ahead and check our database. We still have only 3 records which were seeded here during the agent creation. So we only have 3 records, nothing else. Okay, it's good to verify the database. And now let's create our prompt. And our prompt is create a new customer with the email brown@al.com, name of Jim Brown, and bio of Adventure Extraordinaire. This is a simple human language. We want the LLM to extract key information, populate our SQL query, and create a new record. Let's run this. Okay, so we have something. A record was returned because we have our agent return typed responses, and a customer type was returned with an ID, email, full name, and a bio. And that's good. Let's go and inspect our Supabase database. We still have 3 rows, but once you hit the refresh button on the bottom right, you will see that a 4th row was now added with Jim Brown, and the bio says Adventure Extraordinaire. So our data is in Supabase. That means we have accomplished our objective. Now let's move on to our retrieve tool. We're going to do something similar. The good news is that we don't have to delete the create tool, so we'll keep the create tool. Now we're just going to go into the code and add our retrieve tool. So let's go ahead and do that. The retrieve tool will be very similar to the create tool, but in the retrieve tool, we're only going to pass the email because that's the only thing that we need. And if you look at our query, we're going to do .table customers, select star, where email is equal to email. That's as simple as it gets. And if there's any exception, we're going to raise a value error that a customer with this email was not found. All right, so simple tool. It's the second tool in our agent. Let's see what happens. Our prompt will be retrieve customer details for customer with email brown@al.com. Our LLM will then parse the email brown@al.com, and that's what's going to get passed to the tool, and the tool then will pass it to Supabase. The record was retrieved. Jim Brown, Adventure Extraordinaire was returned. Okay, so that's really good. The information matches the data, the row in Supabase. Now let's go ahead and change that information in Supabase. In Supabase, you can just double click on any column and edit the information there. So let's change the bio for Jim Brown here and make it Great Adventure. Go back to our tool and run our query one more time. And sure enough, we get the updated information. That proves that our agent is indeed doing a real-time access to Supabase, and it's not caching or it's not providing us mocked responses. Great. That is amazing. Let's move on now to our next tool, which will be the update tool. We'll follow a similar structure. Let's write it. It's going to be @agent.tool. We're going to call it update customer by email. And what we're going to pass is the email address, full name, and bio, because those are the pieces of information we'll be updating. We're going to find the customer by email, and we'll update the full name and the bio. This update command is very flexible, and you can update any field that you like, including email. But in this case, we're using the email as the primary identifier for a customer record. Okay, let's continue now. We're going to save our tool and ensure that we have the information available in Supabase. So brown@al.com is there. So let's go ahead and update this record. Now, what we're going to do is we're going to issue the prompt, update customer with email brown@al.com to the new name of James Brown and bio Godfather of Soul. So let's see what happens. The LLM should be able to parse critical information from this prompt and return a customer object with the updated information. As you can see in yellow, we see email brown@al.com, full name is James Brown, bio is Godfather of Soul. Now let's go ahead and check our data inside the Supabase table to verify that indeed it's been updated. We have to hit the refresh button. It doesn't auto refresh, but hit the refresh button And sure enough, we have the updated row in Supabase. That's really awesome. Very, very simple tool, but very effective as well. Let's move on to our last tool. And the last tool will be the delete tool. Again, a very simple tool where we're going to pass an email address and we are going to delete that record. If we don't find the record with that email, we'll just throw a value exception, which then you can handle it any way you like. Let's go ahead and see how our delete tool will work. We're going to define a fourth agent with @agent.tool. We're going to call it delete_customer by email. The only identifier we need to pass is the email address. And our query again is very simple. It's .table customers, .delete, and .equal email and email. That's the only thing we need to pass. This will find the customer by email address and get rid of that record. We first need to ensure that we still have the James Brown record with that email. And sure enough, it's there. We can now launch our script and issue the prompt of delete customer with email brown@al.com. It should return the customer data, but it should be also gone from Supabase. So let's go ahead and refresh our page. And that row is now gone. The record is deleted. Let's go ahead and delete one more. Let's delete the Jim Doe record. The reason I'm doing this is to show you that there are multiple ways you can structure your prompt, but the LLM will be smart enough to extract the email address and only pass that to the tool. So for this one, all we're going to say is delete user jimdoe@gmail.com. In the previous prompt, we had said delete customer with email, this and that. And now we're just saying delete user and just pass an email address. And the LLM will be smart enough to figure it out. If we refresh our Supabase table, sure enough, they're always gone. So that concludes our 4 short tools in the coding part of the tutorial. Now you have one agent with 4 tools. It doesn't matter what prompt you issue to your agent, it will be able to understand and route the request to the proper tool. Okay, now let's summarize. Database Access transforms AI agents from isolated tools into integrated enterprise-ready solutions that can scale, automate workflows, and provide real business value. To become truly intelligent though, AI agents must go beyond the simple stateless processing. They need to handle structured data, maintain consistency, and integrate with existing business systems. So that's where databases come in. They play a critical role in making agents scalable, reliable, and actionable. Thanks for watching. Be sure to like, subscribe, and check out the next video where we'll dive into building UIs for your agents using Streamlit and PydanticAI.